All right, today we are talking about standard 3.2, which is multiplicity of polynomial functions.
So here's the definition of multiplicity from the function, the number of times a given factor appears in the factor form of a polynomial. Write that down. So looking at this example, you can see that the given factor of x minus 2 appears 3 times because it's to the third power. So the number that makes that factor equal 0 is 2. So we have an x-intercept of 2 here, and it has a multiplicity of 3. 3 is the multiplicity on the x-intercept of 2. The other factor is x plus 1. What makes it equal 0 is when x is negative 1, and because it appears twice, it has a multiplicity of 2.
Okay, so 2 slides back, we asked you to make a claim. And so we want to make sure that your claim matches our claim. So our claim is that when the multiplicity of an x-intercept is even, the graph touches the x-axis at that point. When the multiplicity of an x-intercept is odd, the graph goes through the x-axis at that point. So hopefully you listened to me, and now you can pause and write it down. Okay, so slide 3 that you just did is this slide right here. So we have the function y equals x minus 1, and it's being raised to some exponent. So if we pause this right now, my exponent is 2, so that makes this a 2. So the multiplicity at x equals 1 here is 2, which is an even number. And we just said in our claim that when the multiplicity is even, it should touch the x-axis at that point. So if I come over here to x equals 1, there's the point, and my graph is bouncing off right there. It's not going through, so it's touching. So that supports my claim. There's some evidence. Let's check out an odd degree. All right, let's pause it at an odd degree. There's 3. So now my function is x minus 1 to the third. So we have x equals 1 is still our x-intercept because that's what makes the factor equal 0. And it has an odd multiplicity because my degree is 3. And if we look over here at x equals 1, the graph goes through the x-axis. So it does not touch, it goes through. Let's look at 1 just to notice the difference between what happens when it's cubed and it's just to the first power. All right, so it goes through at 3. At 1, it still goes through, but notice it goes through straight. It's not an S-curve. So that's kind of cool how it goes through straight when it's a first degree. And 3, 5, all of those is going to have like an S to it. Okay, so my evidence are the graphs that we just looked at where we were able to change the multiplicity on our x-intercept and see what the graph does. So my reasoning for my claim would be that the graph of the function show that when I have an even degree multiplicity, the graph touches at that x-intercept. It also shows that when I have an odd degree multiplicity, the graph goes through the x-axis at that intercept. So this is how you would write something like this.
All right, so write down this function on the left. So we are looking for our x-intercepts. And when you look at the graph, you notice that there are 2. There's one right here at negative 1. And when you look at the function on the left, where does the x-intercept of negative 1 come from? It comes from this factor right here, because negative 1 would make the factor of 4x plus 4 equal 0. And you can see that it is even multiplicity, and that's why it's touching and not going through. So then we look at the graph again, we see 2 is an x-intercept, and when I look at the function, which factor gives me that? It's this factor of x minus 2 because it equals 0 and x is 2. Notice it has odd multiplicity, so it goes through. Now, there is no other x-intercept, but yet you see this factor of x of 1/7 in the beginning, And you say, well, why doesn't that give me an x-intercept? Because it does not have an x value that would make that factor equal 0. Okay, so now we look at this example. So what are my factors that could make the function equal 0? Well, this first one, 3x, could equal 0 when x is 0. You can write the function equal to 0 and solve and see that. So it would have odd multiplicity because it's the first power, so it goes through. We'll see the graph in a moment to verify this. There's another factor that could make the function equal 0, which is 2x minus 4. So I write it, I copy it down, equal to 0 if I can't in my head. Ms. Gilker's doing a great job of writing with Epic Pen, isn't she?
Terrible.
And when I solve, I get the other x-intercept is positive 2, once again with odd multiplicity, which means it goes through the x-axis.
And odd because you do not see an exponent. So it's an understood 1, and 1 is an odd number.
And now our graph verifies it. We see the graph goes through 0, and the graph goes through 2, as we predicted from the given function.
All right, it's your time to shine. I want you to teach me what you learned. If you have no idea what to write, you made a claim in the Desmos. I told you what your claim should be. So tell me how your claim was different or similar to mine. That's something you could teach me. And we'll go back to the Desmos and do your ground sample. See you later.
Go Tigers and who dat?